This is the example problem that I do with my students after we've developed both of the wave equations. And so this one requires students to find 4 different things from one picture. And it gives you a lot of information that we can use, but I want that to show them that that information can be used to solve multiple different things. And so I have them focus on the speech bubble to start. And so it tells you it takes 5 seconds for one wave to pass. So the seconds is telling us the time it takes for the amount of cycles. And so we can use that information to find frequency by doing the cycles over time, or to find period by doing time over cycles. And so I go through the calculations to get 0.2 hertz for frequency and 5 seconds for period. Another thing that I talk about here is if I knew what the frequency was, I could solve for period by doing 1 over frequency, and vice versa if I found period first. And so that's another way that we could go through it that gives us also the same answer. So now I found period and frequency. Then I asked them to focus on what other information is from the picture, and they focus on the 2 meters, and they tell me that's what the wavelength represents, because we're looking from crest to crest. And so now all we have left to find is speed. And so I asked my students, how would you find speed? And some students say that they would solve for speed by doing the distance 2 meters over time, the 5 seconds. In this case, that would provide them the answer, but I tell them that that's not always going to be the case, that one wave is going to equal the time that they provide to you. And so a better way is to look at the equations we just developed. So we developed the speed equals frequency times wavelength, and speed equals wavelength over period. And so I can use both of these equations because I have frequency and period and wavelength. And so I show them that when you go through this formula, I do 0.2 times 2, that gives me 0.4 meters per second. And then I do my 2 meters divided by 5 seconds, that also gives me 0.4 meters per second. And so this is where I tell my students, if you have the information for both, it doesn't matter to me which way you go about solving for speed, as long as you show me how you found the speed. So this is the example problem I do to show them there's multiple ways to find different quantities, especially in this type of problem.